Hello everyone, glad to be tackling this week object detection algorithms. To be specific, I'm going to tackle YOLO version 4, and I'm also going to be talking about YOLO version 5 by PyTorch. So let us begin. So I'm starting with the YOLO version 4, which is the base architecture was done in darknet. First, I have to show you the models for which I got the YOLO version 4 architectures. So in the YOLO version 4, these are the the variants that are available for the YOLO version 4 in the GitHub repo. So for me, I essentially used a YOLO version 4 where I set the size to 512 by 512, but you can try all the other variants of the YOLO version 4. So the link to the GitHub repo is here available. So then after that, now I'm going to start. I'm going to begin by importing the libraries, that's CV2 for image processing, image reading, NumPy, and time. Then I'm going to set the random seed for reproducibility. And I'm also going to load the coco.names where we find the names of the classes. Then we initialize a matrix from which we find the colors for the classes that have been trained with an YOLO. So after that, I create a decorator function where I use to time the functions that we use throughout this part. This function essentially wraps times a function. So this it calculates the start time and the end time, and then it prints the time taken. So the way a decorator works, you can essentially wrap the function in a decorator, and then you call it now as a modified form. This way it will work. But another way, you can just use an art to essentially say that you are binding the decorator to the function here, and then after that, whenever you call the function, automatically the decorator will automatically also run. To allow for arguments, we'll have to essentially include the args and quirks, and also because the function for which we are binding the decorator returns an output, we have to return an output. So here, since I used YOLOv4, I downloaded the configurations and weights, which I've talked about here. So you essentially download CFG and weights. So these are the configurations and weights. So I now load the YOLO model. Of course, I use a function in CV2, and then I load the configuration and weights. And then after that, I set the preferable backend to be CV2. Then after that, I get the layer names, and then we return the last and connected layer names and the model itself. So, and then after that, now after loading, then we call the load YOLO. So because we have binded the decorator here, essentially automatically, whenever we call load YOLO, we will time the time by which this function is run. So the next part, now we initialize other functions such as read image, which reads the image, resizes it to 512 by 512. Then after that, we return the image. So we also implement another function known as preprocess image, which processes the image with respect to the requirements of the YOLO model. So of course, after reading the image, we divide it by 255 to normalize it. Then we resize it by 512. Then we swap from BGR to RGB, since we know that CV2 loads an image in BGR, so we have to swap to RGB, and then we set crop to false. So this read image will be used whenever we want to show the image. We want to show the image on the output, but this preprocess image is used whenever we want to load the image to the model. So they serve two different purposes. So now we want to time the YOLO inference. That's the time it takes for the image to be passed through the YOLO model and for the outputs to be extracted from the model. So we set the input, which is blob. So we pass the blob. So after passing the image through the preprocess image, we get it to a blob. Now we pass it to the inference. The inference sets the input, does a forward pass, and then we get the outputs. So another function that will time is the function that essentially draws the bounding boxes on the image. So within here we learn so many things, including non-mark suppression. So first of all, get the height and width of the image. So for each outputs that we have received from the forward pass, what we want to do is want to get the 5 highest scoring detections. Then we want to get the highest score, and then we get its class ID, and then we also get its confidence. So we want to determine that if the confidence has surpassed a threshold of 0.5, then we want to get we want to get the detections. Because they are normalized, we have to multiply them by the height and width to normalize them. Then after that, we get the center. So these the 4 values of the detections are center X, center Y, width, and height. So we want to convert them to top left X, top left Y, width, and height. So that's what we do. So this is now the top left X, top left Y. Then we go to, then we get it. Now it's top left X, top left Y, width, and height. So after that, then we essentially get the box, the confidence, and the class ID, and append them to the boxes, confidence, and class IDs, which will initialize here below. So after that, now we do an unmarked suppression in order to reduce the overlapping boxes by the confidence. So, and then we also pass up the threshold to say by what confidence and IOU, which is the intersection of a union, should we remove overlapping boxes to remain with as few boxes as possible which have achieved a given threshold of detection. So after doing an unmarked suppression, we flatten the indexes to achieve a vector, and then we extract the X and Y, the width and height, and then we extract the RGB color, and then we draw the rectangle for the bounding box. Then we get the text for which we format it into a friendly way, and then we put the text onto the image, and then we return the image. So now let's do the actual calling of the images. So finally, of course, this will now render the image after the bounding box has been drawn and the text has been put into the images. So we get the boxes, the confidences, and the class ID. This is where now these are the lists for which we append the values here, here, and here. We're using input host. We're using this image. So after that, now we read the image that this is for rendering, but now the one for leading into the net, into the model. So we preprocess the image. So we get the image, we preprocess it, we pass it through the YOLO inference, which will do a forward pass, and then we get the outputs. After getting the outputs, now we get the outputs and the image, and then we render the bounding boxes and the text on the image, and then we show the image. So let's see the output of the following code. This is the folder for which we have the YOLO TensorFlow.py. So now let me run it. So YOLO TensorFlow. So we see the timing for the loading the model is 0.92 seconds. And then for the inference, we see that it has taken 5.66, and then for the drawing of the detections of the image, we see 0.01. So we see now the detections that have been done. So we see the truck has been detected, the person has been detected, the horse, and the dog. So if you reduce the threshold, it will detect other things within the given image. In this second part of the video, we're going to talk about YOLO version 5, which is implemented in PyTorch by Ultralytics. So the PyTorch folder, I cloned it from the Ultralytics GitHub repo, and I did a few edits. we are going to use the pretend model YOLO version 5 medium. Let's look at the variant details for YOLO version 5, which I extracted from the GitHub repo of Ultralytics. I essentially used this one, so but you can try any variant of the YOLO version 5 and use it in your inference pipeline. So essentially this is what I used. So later after I implement this inference pipeline, I'm going to talk about a brief in terms of the architecture of YOLO version 5 and YOLO version 4. So the first thing that we're going to do is we're going to import from the file YOLO Tutorials. You are going to import model init, load images, show image, preprocess and inference, and non-max suppression. So essentially in the YOLO Tutorials, let's look at the functions, what they do. Model init is the one which essentially helps to load the model. So I'm going to push all these files to GitHub so you can see. So I used absolute path, but you can also use the relative path. So this one essentially will get all the pre-trained models, and then I essentially get the first one, which is now YOLO version 5 medium. So your model init loads the model, load images, essentially reads the images and resizes them. So in case you're adding more images, it will load them, more of them. But for now, since in the inputs folder from which I will load the images, I only have the OS image, I will only load it will only load that one image. Then another function that we've essentially imported is non-max suppression, which you said in the first part of the video that it essentially removes overlapping bounding boxes for which the threshold is not attained. And then another function is show image, which essentially shows the image. If the image is a part of a batch, it will extract that image from the batch and then show it. Otherwise, it will show the image. Then preprocess and inference, essentially what it does, it preprocess the image to prepare it for inference by the YOLO PyTorch model. So it gets the image and converts it into a torch tensor, and then it essentially converts it to a float. Then it normalizes the image, it introduces the batch dimension, and then it permutes the image into the format that PyTorch requires of the model. Then after that, you get the prediction, and then it returns the prediction. So essentially now we've talked about all the functions that we've imported. So now let's import the next functions, that's torch, then CV2 for image loading and processing. We have time, then we have OS. So I've not used the decorator in this part, but you can essentially use the decorator. So globe for getting the paths, so and sys, so numpy and torch. Since my device is like CPU, I'm going to set torch.device to CPU. I don't have CUDA environment. Yeah, so I load the model. Then after loading the model, I get the layer names of the model. Then I also get the colors as per the class names of the YOLO. Then after that, I get the classes. So after getting the classes, I load the images, since we see that it's only as the image of a host. So it only has a single image. So after that, now we look through the path and the image. And since at first the total detections is 0. Then at the beginning of time, now we process and inference the image. So we do the preprocessing and inference, which you saw here. We process the image and then do the inference. After doing the inference, we get the predictions, and then we do now a non-max suppression in order to remove overlapping bounding boxes for which the threshold has not been attained. And then after that, for each prediction in the predictions, we are going to append the prediction, and then we are going to fetch the class. It's first of all the 4 parts of the box, then the class. So the class is the 5th part. So then we cast them to integers. Then we draw the bounding boxes, and then we write the text for the detected classes and the images. By default, it's top left x, top left y, then width and height. So after doing that, now we show the image. So let us run the YOLO version 5 PyTorch inference pipeline and see how it goes. Yeah, so right now we are in the terminal. So when I print, so I'm going to go through to this folder. Then in that particular folder, I'm going to run YOLOtorch.py. So yeah, so when I run it, so as it loads, let us view the YOLO version 4 and YOLO version 5 architecture. So yeah, first of all, this is the link to the models, the pre-trained models of YOLO version 5 by Ultralytics. You can get them in this link, and then so it's running, it's using the layers. So for YOLO version 4, we see that the first part of it is a standard CNN, that's convolution batch, and then we have a mesh activation function. So after that, we see that there's a dense connection block. Then after that, we have a spatial pyramidal polling block, and then we see then the detection block at the end of the YOLO version 4 architecture. So I'll put a link to a nice article detailing YOLO version 4 architecture. Then for YOLO version 5, we see that essentially has three parts. We have a backbone, we have the panet, and we have the output. So in the backbone, we see the bottleneck cross spatial, so something partial networks, so cross-state partial networks, yeah. So cross-state partial networks, and then in the middle part we see concatenation, upsampling, conversion one by one, and then in the output part we see conversion one by one. So that's essentially an overview of the YOLO version 4 and the YOLO version 5 architecture. Yeah, so now let us see the output. So this is the output for YOLO version 5 by Ultralytics, the medium PyTorch pre-trained model version. We see the detections, we see that it's actually pretty good. It's even detecting the small objects in the background, in contrast to the YOLO version 4, which actually did not detect these ones. And we see that, let's see the threshold. I think the threshold, because the other one, the threshold was 0.5. Yeah, so this one I cannot. We'll have to go, I think we'll have to go into the non-mock suppression and see the threshold and all that, but see that it's really good. So yeah, that is all on YOLO version 4 and YOLO version 5. So in the next part, I think I'll have to start from YOLO version 1 to YOLO version 5 and do all that pertains to implementing the architectures and the networks. Yeah, so thank you for watching.